So today we're using trigonometry to find the lengths. You can also use it to work backwards to find the angle. Here's a right angle triangle. I want to find the length that's labelled that I don't know. There are in fact two lengths here that I don't know. But I've labelled one of them with a letter A. The letter indicates, the pronumeral if you prefer, indicates which side I'm interested in finding. This might have been a problem where I was lining something up. I was designing a triangle to fit in somewhere. I knew it would have to be 6 centimetres here and 35 degrees. How tall does my triangle have to be? So, we look at it and we go, let's label the sides. Here's my right angle, so this must be the hypotenuse, opposite the right angle. Here's the angle that I care about, it's 35 degrees. Again, I could work out this angle, but I don't need to. Here's one labelled. So, compared to this angle, this side over here is opposite, and this side here is next to it, and we're going to use the fancy word adjacent for next to. So, hypotenuse, opposite, adjacent. But hold on, I don't even care about this side, do I? Just ignore that. It's not important. Look at what we've got left. Look at what we've got now. There are two sides involved. This one is not. The two sides that are involved are opposite and hypotenuse. Oh. Which of my three trig ratios involve opposite and hypotenuse? Opposite and hypotenuse. Old hags. Some old hags. Sine of my angle is opposite on hypotenuse. Always write the rule first. Helps you avoid silly mistakes later. Okay? Put into my formula what I know. Notice again, I didn't use an O, an op, 3 letters. Sine of my angle. Sine of 35 degrees is A over 6. Okay, how am I going to solve for A? Well, this was A divided by 6. So, to get A by itself, I have to do the opposite of dividing by 6. A is going to be 6 times sine 35 degrees. And because I'm an algebra person, I like algebra. In fact, because I'm a lazy mathematician, I don't like writing things I don't need to. I'm not going to write that times sign. It's there, but I don't need to write it. Okay? So, your calculator, your scientific calculator, knows what the value of sine 35 degrees is. It's a function. You tell your calculator 35 degrees, and your calculator can tell you the sine value. So you just get your calculator, and you say 6 sine 35. Your calculator may not be as good at algebra as you are. You may have to put a times sign here for your calculator. Try it and see. Anyhow, it should tell you that A is 3.441458, and it goes on and on and on and on. Do I actually need that many decimal places? Probably not. I'm measuring a triangle. I've got centimetres here. 1 decimal place would be millimetres. 2 decimal places would be a very, very small amount. So I'm going to round this off to the nearest millimetre, which is, nearest millimetre is this one. So I look at the next digit, it's less than 5, I round down. And it becomes 3.4 centimetres. Easy as that. Try another one. Okay. Here's a right angle triangle. I have to work out the labelled length I don't know. Alright, let's label the sides of the triangle. Here's my right angle, which means this is the hypotenuse. Oops, hypotenuse. Here's my angle that I know and that I care about. So this side is opposited, and this side is next to it, adjacent to it. In fact, I don't even care about this side, do I? So I can ignore that. Which sides have I got? I've got adjacent and hypotenuse. So which of my three trig ratios do I want? Adjacent and hypotenuse. Here, cosine. You need to think through either SOHCAHTOA, AH, cosine. Or you can say A and H together, always hide. Can't always hide. Cos. There we go. Alright, write the rule. Cos of my angle is adjacent on hypotenuse. Notice again, I always have to have an angle. Give it a name. Write the formula properly. Okay, put into the formula what you know. Cos of 32 degrees, adjacent is f, hypotenuse is 3.46. Okay, this is f divided by 3.46. So to find f, I have to multiply. 3.46 cos 32 degrees. Calculator. 3.46 cos 32 degrees. F is 2.9. Oh, how far am I going to go? 3, 4, 2, 4, 6, 4, 1, 3. I probably don't need that many digits, do I? Well, here I've got metres and I've got a measurement to the nearest centimetre. So wouldn't it be sensible to give a measurement the same to the nearest centimetre? So that's 2 digits, with my laser on, that's 2 digits. The next digit is less, so I round down, 0.93. 2.93 metres. Too easy. Another example. Okay, right angle triangle, 70 degrees, 7 centimetres. Alright, let's label the sides. This is the hypotenuse, opposite the right angle, but I don't care, so I'm not even going to bother labelling it this time. This side, oh, there's my angle, so this side is opposite that angle, and this side is adjacent to that angle. Let's work it out. So, opposite and adjacent. Adjacent and opposite. Opposite and adjacent is tan, TOA, their old age. So, tan theta is opposite on adjacent. And if you need to, go back to where you wrote it down the first time, or write it down again, or just write SOHCAHTOA. You might even like to write it like this. Some old hags can't always hide their old age. And that gives you a hint for which one's on top. Opposite and adjacent is tan. Okay, so put in what you know. Tan of 72 degrees is m over 7. Alright, m divided by 7, do the opposite. M is 7 tan 72 degrees. Your calculator knows what opposite on adjacent is for any right angle triangle with 72 degrees. So ask it. 7 tan 72. M is 21.5. Oh, how far am I going? Centimetres. You know, again, probably millimetres will do. It's 21.54, and it goes on from there, but I only need this much. If I want to go to millimetres, This number is less than 5, round down again. 0.54 centimetres. Very straightforward.